Lituya Bay, located in the southeastern part of Alaska, may appear to be a quiet, peaceful fjord, but it has a history of terrifying and destructive power that most people don't even know about. On July 9, 1958, Lituya Bay became the site of one of the most shocking natural events ever recorded, a megatsunami that reached a mind-blowing height of 1,720 feet. To put that into perspective, that's taller than the Empire State Building, and no tsunami before or since has ever come close to matching that record. The event began with a massive landslide when an enormous chunk of rock, estimated to be around 30 million cubic yards in size, suddenly plunged into the bay. This was no ordinary landslide. The force of the rocks crashing into the water sent a powerful wave surging up and over the surrounding cliffs, creating a tsunami of catastrophic proportions. The wave tore through the narrow bay at an incredible speed, wiping out everything in its path. It was so powerful that it even stripped trees from the mountainsides, leaving behind a barren landscape where the lush forest had once stood. Despite how incredible and destructive the megatsunami was, there were only a few eyewitnesses. The most well-known of these witnesses were the people aboard the fishing boat, the Lynn, a vessel that was near the bay when the event occurred. The crew of the Lynn had a front row seat to the incredible wave as it hurtled toward the shore. They managed to survive, but the impact of the megatsunami left them in awe of nature's raw power. What happened at Lituya Bay in 1958 raises a lot of questions, some of which still don't have clear answers. How exactly did the landslide happen? Was it purely a natural event, or did human activity, such as logging or other environmental factors, contribute to the disaster? And could something like this happen again? The sheer magnitude of the megatsunami's height and its unexpected nature have led to many speculations and studies over the years, but there's still no concrete understanding of all the factors involved. As scientists continue to study Lituya Bay and its unusual geography, the mystery deepens. The bay is surrounded by steep cliffs that create a narrow, confined space. This trapped environment amplifies the force of natural events, making Lituya Bay a particularly dangerous and unstable place. The landscape, combined with the ongoing tectonic activity in the region, sets the stage for even more potential disasters in the future. Scientists have learned that the same geological forces that caused the megatsunami of 1958 are still at play today, meaning that Lituya Bay's danger has never fully passed. As we move forward, we'll dive deeper into the science behind what happened in 1958 and explore the ongoing risks that this place faces. Stay tuned as we continue this journey through one of the most fascinating and dangerous natural events in history. In order to understand the full scale of the 1958 megatsunami in Lituya Bay, we need to explore the geological forces that made it possible. The event didn't happen randomly. The bay is situated in a region with a unique and volatile combination of factors that make it prone to natural disasters, especially ones as destructive as a megatsunami. Lituya Bay is a narrow fjord, which means it's a body of water surrounded by steep, towering cliffs. The geography here is a major part of what turned a landslide into a record-breaking tsunami. When the rock slide occurred on that fateful day in July, the steep cliffs funneled the massive amount of energy from the falling debris into a concentrated area. This caused the water to rise with such force that the wave reached an unimaginable height. With nowhere for the energy to escape, the force of the water surged upward rather than spreading out over a larger area. It created a tsunami that was much more powerful than what you'd typically see in the open ocean, but what made this particular landslide so massive? For starters, the region around Lituya Bay is incredibly seismically active. The Pacific and North American tectonic plates are constantly shifting, and the pressure between them builds up over time. This ongoing movement of the Earth's crust can trigger massive earthquakes, which in turn can cause landslides. In fact, it's believed that the landslide that triggered the megatsunami was caused by a relatively small earthquake, measuring about 7.8 on the Richter scale. While not a huge earthquake by some standards, it was enough to send tons of rock crashing into the bay. The landslide itself wasn't just a random event. It was part of the complex natural forces that had been at play in the region for thousands of years. The bay's geological history is filled with tectonic activity, and its physical structure makes it prone to events like this. With steep cliffs and a narrow channel, the water in Lituya Bay is essentially trapped in a confined space. When something like a landslide occurs, the water doesn't have much room to spread out, and it ends up pushing straight up and over the cliffs, creating a catastrophic wave. Adding to the danger of the bay is the region's high level of seismic activity. Earthquakes are a regular occurrence, and while most are small, larger ones can trigger events like the landslide that led to the Megatsunami. The energy released from these earthquakes can shake loose unstable rock formations, triggering massive rock slides into the bay. This, combined with the topography of the bay itself, creates a perfect storm for disaster. Understanding the geological makeup of Lituya Bay helps explain why this megatsunami was so devastating, but it also raises important questions about future events. The forces at work here haven't gone away. In fact, they're still very much present. The same tectonic activity that triggered the 1958 disaster could cause similar events to occur again. With ongoing seismic activity in the region, Lituya Bay remains a place of concern for scientists studying the area. As we move on, we'll look at the aftermath of the Megatsunami and how scientists have studied its effects. Despite its terrifying nature, this event has provided valuable insights into the power of natural disasters and the ways we can better understand and prepare for them in the future. The aftermath of the 1958 Lituya Bay Megatsunami was both stunning and sobering. The destructive wave, which reached an unimaginable height of 1,720 feet, left an indelible mark on the landscape and offered valuable insights into the forces that shape our planet. In the hours and days following the disaster, scientists and survivors began to grasp the full scope of the devastation. The most immediate and visible effect of the megatsunami was the widespread destruction of the surrounding forest. As the wave surged up the cliffs and crashed into the mountains, it stripped trees from the slopes, leaving behind a barren and eerie landscape. The water's sheer force was so great that it uprooted massive trees and left them scattered across the bay, some of them still floating in the water long after the event. The power of the wave was undeniable, and its impact on the environment was clear. Not only were trees destroyed, but the wave also caused significant erosion along the cliffs, leaving scars on the land that are still visible today. Remarkably, the megatsunami's effects were not limited to just the surrounding environment. The local population, who lived in small villages near the bay, were lucky to escape the full force of the disaster. While there were no fatalities directly linked to the megatsunami itself, the event did cause major disruptions to local communities. The destruction of land and wildlife affected the livelihoods of those who depended on the region's natural resources for survival. Despite the isolated nature of the bay, the force of the event was felt across the surrounding area, and the cleanup and recovery process was long and difficult. One of the most fascinating aspects of the 1958 megatsunami is the fact that only a few people witnessed the event firsthand. A small number of boats were in the bay at the time, and while most were able to escape the brunt of the wave, one fisherman and his family were in a boat near the shoreline when the wave struck. Their accounts provide an eerie glimpse into the terrifying power of the disaster. As the wave hit, the water in the bay suddenly surged, and they reported seeing the mountain cliffs on either side of them disappear into a wall of water. The fisherman and his family were lucky to survive, but their experience is a vivid reminder of the destructive potential of such an event. The scientific community was quick to respond to the megatsunami, conducting studies to understand its full scope and the forces that made it possible. Researchers used a combination of eyewitness accounts, geological surveys, and data from nearby seismic stations to piece together the puzzle of what had happened. What they discovered was a rare and unusual event that, while not common, could potentially happen again. The megatsunami in Lituya Bay was not just a freak accident, but rather a reminder of the raw power that exists in Earth's geological processes. As researchers began to analyze the event, they realized that the Lituya Bay Megatsunami was unique, not only because of its extreme height, but also because of the specific conditions that made it possible. It was the perfect storm of seismic activity, topography, and geology that resulted in the massive wave. In a way, the disaster offered a rare opportunity for scientists to study how large-scale landslides and earthquakes can create such intense tsunamis, something they may not have been able to study under normal circumstances. Looking forward, scientists began to consider what the future might hold for Lituya Bay. While the region's seismic activity had been relatively stable in the years since the 1958 megatsunami, the underlying geological factors that caused the disaster are still very much in play. The Pacific and North American tectonic plates continue to shift, and the possibility of another landslide or earthquake remains a real threat. But what makes Lituya Bay particularly dangerous is its location and its ability to amplify the effects of such events. The bay's narrow, enclosed shape funnels the energy of any seismic or landslide event directly into the water, making it a potential breeding ground for another megatsunami. As we move forward in this story, it's important to consider how the Lituya Bay Megatsunami has shaped our understanding of natural disasters and the science behind them. The lessons learned from this event continue to inform the ways we study and prepare for similar events in the future, highlighting the need for more research into the dynamics of earthquakes, landslides, and tsunamis. The events of July 9th, 1958 may be long behind us, but the lessons they left us with are still very much relevant today. As we reach the conclusion of the Lituya Bay Megatsunami story, it's important to reflect on the lasting impact the event has had on both scientific research in the local area. The 1958 megatsunami was a game changer for the way we understand the power of nature and the destructive potential of tsunamis. Despite the rare and isolated circumstances of this event, it has sparked ongoing investigations into similar areas around the world, all of which have the potential to experience a similar catastrophe. One of the most significant consequences of the megatsunami was the heightened awareness it brought to the vulnerability of coastal areas that are situated near active geological zones. As a result, scientists began to study how earthquakes and landslides could trigger tsunamis in other regions with similar topographical and seismic conditions. While Lituya Bay is an extreme case, the principles of how it all unfolded have been applied to better understand tsunamis in general, especially those that might occur along the Pacific Ring of Fire, where tectonic activity is high. Although there were no fatalities directly linked to the megatsunami, the disaster highlighted the importance of early warning systems and preparedness in regions at risk for tsunamis. The speed at which the waves surged through Lituya Bay left little time for people to respond, making it clear that places with a history of seismic activity need to be on high alert. In the years following the event, efforts to improve tsunami warning systems became a priority for many coastal regions around the world. Scientists also started to look more closely at the effects of large landslides and how they could trigger waves, a crucial element in preventing or mitigating future disasters. The unique and isolated geography of Lituya Bay has also made it a focal point for geological studies. Researchers continue to study the bay and its surroundings to this day, gathering data on its ongoing seismic activity and the state of its landscape. The potential for another major landslide or earthquake is still very much a possibility, and while it may be impossible to predict exactly when or where the next catastrophic event will strike, the lessons learned from the 1958 megatsunami have paved the way for better preparedness and understanding of similar events elsewhere. What is perhaps most striking about the Lituya Bay Megatsunami is the sheer power of nature. It serves as a reminder that even in the most peaceful and remote locations, the Earth's forces are always at work, shaping and reshaping the landscape in ways we can't always predict. This disaster may have been an extreme and rare event, but it's one that serves as a warning that nothing on Earth is immune from the power of natural forces. In the years since the disaster, the memory of the megatsunami has lingered, both in the scientific community and in the local memory. It stands as a testament to nature's ability to surprise us and remind us of how little control we truly have over the forces that shape our world. Lituya Bay may seem quiet and peaceful today, but it still holds the potential for the kind of sudden, devastating event that forever alters the landscape. As we finish reflecting on the events of July 9th, 1958, it's clear that Lituya Bay continues to be a unique geological and environmental location that holds important lessons for all of us. It's a reminder that while we may not be able to control or fully predict these catastrophic events, understanding and respecting the natural world around us is essential for surviving and navigating the unpredictability of life on Earth. And who knows, perhaps one day scientists will uncover even more secrets hidden in the depths of Lituya Bay. Until then, we continue to study, learn, and prepare, taking the lessons of the past to better understand the future. On May 12th, 2008, at precisely 2:28 p.m. local time, the Earth unleashed its fury in one of the most devastating natural disasters in modern Chinese history. A powerful earthquake struck Sichuan province in southwestern China, measuring 8.0 on the Richter scale, according to the China Earthquake Administration. The U.S. Geological Survey, USGS, recorded it as a magnitude 7.9. But regardless of the numbers, the earthquake's strength was monumental. Its epicenter was located in Wenchuan County, approximately 50 miles northwest of Chengdu, the provincial capital. This rural area, surrounded by steep mountains and narrow valleys, became the epicenter of destruction. The quake was caused by the movement along the Longmingshan Fault, a tectonic plate boundary where the Indian and Eurasian plates collide. This fault zone has been geologically active for millions of years, and the immense pressure between these two plates finally gave way, resulting in the massive release of energy. The seismic event caused the ground to rupture along a fault line stretching nearly 240 kilometers, about 150 miles. In some places, the ground shifted laterally by as much as 9 meters, nearly 30 feet. The force released by this earthquake was equivalent to the detonation of multiple nuclear bombs, and its impact was felt across East Asia. What made this earthquake particularly devastating was not just its magnitude, but its shallow depth of only 19 kilometers, about 12 miles. Shallow earthquakes tend to cause more severe surface shaking, amplifying their destructive power. The tremors lasted for about 2 minutes, an eternity for those caught in its grip. It wasn't just a local event. The earthquake sent shock waves across a wide area. People as far away as Beijing, Shanghai, and even Hanoi, Vietnam, over 1,500 kilometers away, reported feeling the ground tremble. The seismic activity didn't just shake the ground, it shook the lives of millions. The towns and villages near the epicenter, including Beichuan, Yingxiu, and Duzhengyan, bore the brunt of the devastation. In Wenchuan County, where the epicenter was located, up to 80% of structures were either damaged or completely destroyed. Schools, homes, hospitals, and government buildings crumbled into heaps of rubble, trapping countless individuals beneath. Roads cracked open, bridges collapsed, and power lines snapped, plunging many areas into darkness. In the span of just a few minutes, bustling communities were reduced to ruin. The earthquake's timing added to the catastrophe. Striking in the early afternoon, many children were at school and workers were inside office buildings. Tragically, thousands of students were killed when their school buildings collapsed, exposing critical flaws in construction standards. This led to widespread anger and heartbreak among parents, who would later refer to these poorly built schools as tofu buildings due to their weak and unstable structures. Within minutes of the main quake, the region was hit by a series of aftershocks, some exceeding a magnitude of 6.0. These aftershocks not only caused additional destruction, but also made it nearly impossible for survivors to seek safety. Landslides triggered by the tremors buried entire villages, dammed rivers, and created quake lakes that pose new threats of flooding. For those who survived the initial shock, the danger was far from over. As news of the earthquake spread, a sense of dread gripped the nation. Sichuan province, known for its breathtaking natural beauty and vibrant culture, was now the epicenter of unimaginable tragedy. For the millions of people affected, life as they knew it had been irrevocably changed. The earthquake wasn't just a geological event, it was a humanitarian crisis that would require an unprecedented response. This catastrophic moment marked the beginning of a period of intense rescue and recovery efforts. But for the people of Sichuan, it was also the beginning of a long and painful journey to rebuild their lives. The Sichuan earthquake of May 12, 2008, was not a random event, but the result of complex geological forces at work over millions of years. To understand why this disaster occurred, one must delve into the tectonic processes that shaped the region and made it a hotspot for seismic activity. Sichuan province is situated near the edge of the Tibetan Plateau, one of the most geologically active regions in the world. The plateau itself was formed as a result of the collision between the Indian and Eurasian tectonic plates, a process that began approximately 50 million years ago. This slow-motion collision continues today, with the Indian plate pushing northward at a rate of about 5 centimeters, 2 inches per year. This movement generates immense stress along fault lines in the region, particularly the Longmingshan Fault, which runs along the eastern edge of the Tibetan Plateau and cuts through Sichuan. The Longmingshan Fault is a thrust fault, meaning that one side of the fault is forced upward over the other due to tectonic pressure. Over time, stress builds up along the fault line until it surpasses the strength of the rock, causing the fault to rupture and release energy in the form of an earthquake. In the case of the Sichuan earthquake, the rupture occurred along a 240-kilometer, 150-mile segment of the fault, with the ground on either side shifting violently. This seismic event was classified as a megathrust earthquake, one of the most powerful types of earthquakes. These occur when a massive slab of the Earth's crust is pushed upward, releasing an enormous amount of energy. The Sichuan quake released an estimated 3 exajoules of energy, equivalent to the detonation of nearly 500 million tons of TNT. The ground shaking caused by this release of energy was intense, with peak ground accelerations exceeding 1 g-force in some areas. This level of shaking is strong enough to toss objects into the air and bring down even well-built structures. The timing of the earthquake was particularly unfortunate. It struck at 2:28 in the afternoon when many people were indoors, increasing the likelihood of fatalities and injuries. The rupture was also shallow, occurring at a depth of 19 kilometers, 12 miles. Shallow quakes tend to be far more destructive because the energy they release is concentrated close to the surface, where buildings, infrastructure, and people are located. The geology of the region also played a critical role in amplifying the quake's destructive power. The Sichuan Basin, located just east of the Tibetan Plateau, is filled with loose sedimentary layers that are prone to liquefaction during strong earthquakes. Liquefaction occurs when saturated soils lose their strength and behave like a liquid due to intense shaking. This phenomenon caused buildings to sink or tilt in many areas, further contributing to the devastation. Another factor that worsened the impact was the steep and rugged terrain surrounding the epicenter in Wenchuan County. The mountains in this region are geologically young and composed of fractured rock, making them highly susceptible to landslides during seismic events. The earthquake triggered thousands of landslides, some of which buried entire villages and blocked major rivers. These landslides created what are known as quake lakes, where debris dams rivers, forming temporary reservoirs. In some cases, these quake lakes threatened to burst, putting downstream communities at risk of catastrophic flooding. The earthquake's massive energy release and widespread destruction highlight the inherent vulnerability of the region. Despite being located in a seismically active zone, much of the area was unprepared for such a disaster. Many of the buildings that collapsed were constructed with inadequate materials and methods, unable to withstand the intense shaking. Schools in particular suffered disproportionately high levels of destruction, leading to tragic loss of life among children. In the hours immediately following the earthquake, aftershocks began to ripple through the region. These secondary quakes, some exceeding a magnitude of 6, added to the destruction and hampered rescue efforts. The strongest aftershock occurred on May 27th, measuring 6.4 in magnitude, further destabilizing the already fragile region. Over 178,000 aftershocks were recorded in the months following the main quake, a grim reminder of the ongoing geological instability. The Sichuan earthquake was a stark demonstration of the forces at play beneath the Earth's surface. It revealed the immense power of tectonic processes and the fragile balance that exists between the natural world and human settlements. For the people of Sichuan, this understanding came at a tremendous cost as the ground beneath their feet betrayed them in one of the most devastating ways imaginable. The Sichuan earthquake of May 12, 2008, brought widespread devastation, reshaping entire cities and leaving deep scars on the communities it touched. The quake's epicenter, located near Wenchuan County, saw unparalleled destruction, but its effects rippled out across Sichuan province and beyond, impacting millions of lives. Wenchuan County, home to over 100,000 people, bore the brunt of the earthquake. Entire towns were leveled within seconds as buildings collapsed under the immense forces of the quake. Public facilities, schools, and hospitals were among the hardest hit, their poorly constructed structures unable to withstand the seismic waves. In Beichuan County, another area near the epicenter, over 80% of the buildings were reduced to rubble. The picturesque town of Beichuan, nestled in a valley, was buried under landslides triggered by the quake, erasing it from the map. Larger cities like Dujiangyan, Mianyang, and Chengdu also faced significant damage. In Dujiangyan, a city known for its ancient irrigation system, modern buildings collapsed alongside historical structures. Mianyang, home to millions, saw entire residential complexes pancaked, trapping thousands of people under debris. Even Chengdu, the provincial capital located over 90 kilometers, 56 miles from the epicenter, experienced substantial destruction. Though Chengdu's modern infrastructure fared better than rural areas, older buildings, particularly in densely populated neighborhoods, suffered heavy damage. The human toll was staggering. Official records later confirmed that over 69,000 people lost their lives, but the real number may be even higher. Another 17,575 were reported missing and presumed dead. Beyond this, 374,640 people sustained injuries, many of them life-altering. In some of the hardest-hit areas, entire families were wiped out. Schools, tragically, became the sites of some of the greatest loss of life. In Beichuan Middle School, over 1,000 students and teachers perished when the building collapsed. Across Sichuan province, it is estimated that as many as 5,335 children died in their schools, sparking outrage and calls for accountability over substandard construction practices. These poorly built tofu dreg schools, so named for their fragile, crumbling materials, became symbols of the tragedy. The earthquake severely damaged critical infrastructure, isolating many towns and villages from the outside world. Roads leading to Wenchuan and other affected areas were destroyed by landslides, cutting off access for rescue teams. Bridges collapsed, including the Zipingpu Bridge near Dujiangyan, severing key transportation links. Rail lines were warped, tunnels collapsed, and highways were rendered impassable. Even the Chengdu Shuangliu International Airport experienced disruptions, further delaying relief efforts. Communication networks were also crippled, telephone lines were cut, and mobile towers toppled, leaving millions unable to contact loved ones or call for help. Electricity and water supplies were interrupted in vast swaths of the province. Hospitals, many of which were damaged or destroyed, were overwhelmed with casualties. Makeshift triage centers were set up in streets and parks, but the lack of medical supplies and personnel made it impossible to treat everyone in need. As if the earthquake itself were not enough, its aftermath brought additional hazards. Landslides triggered by the quake buried entire villages and blocked major rivers, creating a series of quake lakes. The largest of these, Tangjiashan Lake, formed when landslides blocked the Jian River near Beichuan County. The rapidly rising water levels posed a grave risk to downstream communities, with fears of catastrophic flooding. Tens of thousands of residents had to be evacuated, as engineers and soldiers worked tirelessly to drain the lake and stabilize the debris dam. The destruction of dams and reservoirs in the region added to the dangers. The Zipingpu Dam, located just a few kilometers from the epicenter, sustained significant structural damage. Had the dam failed, it could have unleashed a devastating flood, further compounding the loss of life and property. In addition to the physical devastation, the earthquake left an emotional scar on the people of Sichuan. Families were torn apart, with many losing loved ones in the blink of an eye. Survivors faced the daunting task of identifying bodies and saying goodbye to those they had lost, often in mass graves or hurried cremations due to health concerns. Cultural heritage sites were also affected. The ancient Dujingyan irrigation system, a UNESCO World Heritage Site, sustained damage, though its primary structures remained intact. Temples, pagodas, and other historical landmarks crumbled, taking with them centuries of history and cultural significance. The scale of destruction shocked not only Sichuan but the entire nation. Within hours of the quake, news of the disaster spread across China, prompting an outpouring of grief and solidarity. Flags were lowered to half-mast and public events were cancelled as the nation mourned its losses. Millions tuned in to broadcasts of rescue efforts, hoping for news of survivors. The immediate aftermath of the Sichuan earthquake revealed the fragility of human life in the face of nature's fury. Cities were shattered, lives were lost, and families were torn apart, leaving a province and a nation reeling from the devastation. But amid the destruction, the resilience of the human spirit began to shine through, setting the stage for the monumental rescue and relief efforts that would follow. The aftermath of the Sichuan earthquake on May 12, 2008 revealed the immense challenges of recovery and the extraordinary resilience of the human spirit. As the ground stopped shaking, the true scope of the disaster came into focus, setting in motion one of the largest relief efforts in modern history. This final part examines the aftermath of the earthquake, the reconstruction efforts, the long-term impact on affected communities, and the enduring lessons learned. In the hours following the quake, China faced a monumental task: rescuing survivors, caring for the injured, and providing shelter to millions who had lost their homes. The Chinese government, recognizing the unprecedented scale of the disaster, declared a national emergency and mobilized tens of thousands of soldiers, police officers, and volunteers. Helicopters, trucks, and even makeshift rafts were employed to reach isolated areas, often navigating treacherous terrain left unstable by landslides. Time was of the essence. The first 72 hours after an earthquake are critical for rescuing those trapped under debris. Rescuers worked tirelessly, often digging with their hands or rudimentary tools, as heavy machinery could not access many remote locations. Heroic stories emerged, such as the rescue of a young girl pulled from the rubble of Sichuan Middle School after 70 hours. Yet for every life saved, there were countless others lost, their absence leaving families shattered. The disaster prompted an outpouring of support from within China and across the globe. Domestically, citizens and businesses donated money, supplies, and time. In a rare moment of unity, people from all walks of life set aside differences to contribute to the relief efforts. Telethons raised billions of yuan, while food, water, and clothing poured into Sichuan from every corner of the country. Internationally, offers of assistance came from over 100 countries and organizations. Nations such as Japan, the United States, and Russia sent rescue teams, medical personnel, and equipment. The World Health Organization and the Red Cross provided medical supplies and expertise, while the United Nations coordinated logistics to ensure aid reached those most in need. This level of international cooperation underscored the shared humanity that disasters bring to light. One of the most pressing challenges was providing shelter for the over 4 million people left homeless by the earthquake. Temporary tent cities sprang up almost overnight, dotting fields and open spaces across Sichuan. While these shelters provided immediate relief, they lacked basic amenities such as clean water, sanitation, and adequate protection from the elements. Diseases such as dysentery and respiratory infections began to spread, adding another layer of urgency to the relief efforts. The government and aid organizations worked quickly to establish more stable solutions. Prefabricated housing units were erected in large numbers, providing a semblance of normalcy for displaced families. Schools and clinics were set up within these settlements, ensuring children could continue their education and medical needs could be addressed. However, the psychological scars of the disaster were harder to mend. Counseling services were introduced, focusing on children who had witnessed the loss of friends, teachers, and family members. The scale of destruction required a comprehensive, long-term approach to rebuilding. In September 2008, the Chinese government unveiled a massive reconstruction plan with a budget of over 1 trillion yuan, equivalent to approximately $146 billion at the time. The plan aimed to rebuild homes, schools, hospitals, and infrastructure with an emphasis on safety and sustainability. One of the most ambitious projects was the relocation of entire towns. For instance, the devastated town of Beichuan was rebuilt on a new site several kilometers away, with modern earthquake-resistant structures. The old town was preserved as a memorial, a haunting reminder of the lives lost and the power of nature. Other towns and villages were similarly relocated or rebuilt with improved designs to minimize future risks. In addition to physical reconstruction, the government prioritized economic recovery. Subsidies were provided to farmers to replace lost livestock and replant crops, while small businesses received financial assistance to restart operations. Larger industries such as manufacturing and tourism were incentivized to invest in the region, creating jobs and stimulating the local economy. The earthquake left deep emotional scars on survivors, many of whom lost multiple family members. The grieving process was compounded by the sheer scale of the disaster, with entire communities mourning their dead. In response, memorials and monuments were erected across Sichuan. Annual commemorations on May 12th serve as both a remembrance of those who perished and a testament to the resilience of the survivors. In Beichuan, the remains of the old town were turned into a national earthquake memorial site, drawing visitors from around the world. Schools, such as Juyuan Middle School, where hundreds of students lost their lives, became places of pilgrimage, with flowers, photos, and messages left in tribute to the young lives cut short. The Sichuan earthquake exposed weaknesses in building codes and disaster preparedness, prompting significant reforms. Stricter construction standards were implemented nationwide, with an emphasis on ensuring schools, hospitals, and other public buildings could withstand future earthquakes. Emergency response protocols were also overhauled, with greater investment in training, equipment, and public awareness campaigns. The disaster also highlighted the importance of international cooperation in addressing large-scale emergencies. China's openness to foreign assistance during the crisis marked a significant shift in its approach to humanitarian aid, fostering closer ties with global partners. The Sichuan earthquake was one of the most devastating natural disasters in China's history, but it also demonstrated the resilience of the human spirit. from the heroic efforts of rescuers to the generosity of strangers. The response to the disaster showcased humanity at its best. While the scars of the earthquake remain, the people of Sichuan have rebuilt their lives and communities with determination and hope. The legacy of the earthquake is a reminder of both the fragility of life and the strength that emerges in the face of adversity. For those who lived through it, May 12, 2008, will forever be a day of sorrow and remembrance, but also a testament to the power of resilience and the enduring bonds of humanity. Mount Redoubt, a towering stratovolcano in southern Alaska, stood silent for over 20 years before showing signs of an awakening in late 1989. Nestled within the Aleutian Range, this massive volcano had a history of eruptions, but its long dormancy had lulled many into a sense of security. However, beneath its seemingly tranquil exterior, forces were building that would soon make headlines across the globe. In the months leading up to the eruption, subtle shifts in the volcano's behavior caught the attention of scientists. Small but persistent earthquakes rippled through the ground, a telltale sign of magma movement deep within the earth. The frequency and intensity of these tremors gradually increased, hinting that Mount Redoubt was preparing for something significant. Steam emissions from the summit vents became more frequent, and the surrounding glaciers began to show signs of melting. The United States Geological Survey, USGS, closely monitored these changes, piecing together the clues of the impending eruption. At that time, volcanic monitoring technology was not as advanced as it is today. Instruments like seismometers and tilt meters provided critical data, but they were limited in their ability to predict the exact timing or magnitude of an eruption. This uncertainty left scientists and local residents alike in a state of constant vigilance, waiting for the inevitable. The region around Mount Redoubt, known for its rugged beauty, was home to scattered communities, small towns, and vital infrastructure. The nearby Drift River Terminal, a facility used for storing and shipping crude oil, was a major concern. Its proximity to the volcano made it highly vulnerable to the potential hazards of an eruption, such as ashfall, lahars, and pyroclastic flows. Preparations to mitigate risks were underway, but no one could predict the scale of what was to come. By early December of 1989, the seismic activity had reached a fever pitch. Earthquakes were now occurring in rapid succession, and steam plumes rose ominously from the summit. The USGS issued alerts warning of a likely eruption. Local authorities coordinated emergency plans, and residents prepared for the worst, stocking up on supplies and making evacuation plans. Despite these efforts, the sense of unease lingered. As the days ticked by, tension grew. The world turned its eyes to Alaska, captivated by the dramatic buildup of one of nature's most powerful forces. Scientists worked tirelessly to decipher the signals coming from Mount Redoubt, knowing they were witnessing a prelude to a significant geological event. The stage was set, and the volcano's long slumber was about to end in spectacular fashion. On December 14, 1989, Mount Redoubt ended its years of dormancy with a sudden and dramatic eruption. It began with a powerful explosion that sent a towering column of ash and gas spiraling nearly 10 miles into the atmosphere. This was the first in a series of eruptions that would last for months, each more unpredictable than the last. The initial eruption coated the nearby landscape in a thick layer of volcanic ash, turning daylight into a dim, gray haze. For the people living in the surrounding areas, this marked the start of a challenging and chaotic period. The ash cloud, propelled by strong winds, spread far beyond the volcano, affecting communities hundreds of miles away. Air travel, a lifeline in Alaska's vast and often remote regions, came to a standstill. Anchorage, the state's largest city, saw its airport operations severely disrupted as ash particles posed a serious threat to aircraft engines. Flights were grounded or rerouted, and travelers were left stranded. Pilots navigating the airspace faced the daunting task of avoiding the massive ash plume, which could cause catastrophic engine failure if encountered. The eruption also unleashed another dangerous phenomenon, lahars. These fast-moving torrents of volcanic mud and debris formed as the heat from this eruption melted the glaciers and snow on Mount Redoubt's summit. The lahars surged down the mountain's flanks, carving paths of destruction through valleys and waterways. One of the most notable impacts was at the Drift River Terminal, where crude oil tanks were directly in the path of these devastating flows. Emergency crews worked around the clock to protect the facility, building berms and pumping out oil to prevent a potential environmental disaster. For weeks, Mount Redoubt continued to erupt intermittently, with each event bringing new challenges. Volcanologists documented pyroclastic flows, searing avalanches of hot gas and rock that raced down the mountain at incredible speeds, obliterating everything in their path. These flows not only reshaped the terrain, but also created significant hazards for those attempting to study or manage the eruption's effects. The ongoing eruption forced many residents to evacuate their homes, leaving behind their belongings and livelihoods. Schools and businesses closed, and communities struggled to adapt to the new reality of living under the shadow of an active volcano. Emergency shelters were set up, and local governments coordinated efforts to distribute clean water and medical supplies to those in need. The ashfall contaminated water supplies, clogged machinery, and created respiratory issues, particularly for children, the elderly, and those with pre-existing health conditions. Scientists working on the ground faced immense challenges as well. The conditions were harsh, with ashfall reducing visibility to mere feet and coating their equipment in fine abrasive dust. Despite these difficulties, their efforts to monitor and study Mount Redoubt provided critical information that helped guide emergency responses and protect lives. As the eruptions continued into early 1990, it became clear that this was no ordinary volcanic event. The sheer scale and intensity of Mount Redoubt's activity captured the world's attention, highlighting both the destructive power of nature and the resilience of the communities affected. As Mount Redoubt's eruptions intensified in early 1990, the volcano unleashed some of its most powerful and dramatic displays. The ash plumes grew larger, frequently reaching altitudes of over 40,000 feet, and disrupted air travel, not just within Alaska, but across significant portions of North America. The fine volcanic ash particles carried by the wind spread as far as parts of the lower 48 states and Canada, creating a widespread environmental and logistical challenge. One of the most significant hazards during this period was the impact on aviation. Volcanic ash is notorious for its ability to cause severe damage to aircraft engines, potentially leading to in-flight engine failure. A particularly harrowing incident occurred in December 1989 when a KLM Royal Dutch Airlines flight encountered the ash cloud. The Boeing 747's engines all failed mid-flight, leaving the massive jetliner in a dangerous glide. Miraculously, after multiple attempts, the pilots managed to restart the engines, narrowly avoiding disaster. This close call underscored the critical need for real-time volcanic monitoring and prompted aviation authorities to establish better protocols for volcanic ash avoidance. Back on the ground, the lahars continued to wreak havoc. As the eruptions melted the extensive glacial ice atop Mount Redoubt, these destructive mudflows grew in size and frequency, cutting through valleys and river systems. They repeatedly threatened infrastructure like the Drift River oil terminal, where protective measures were constantly tested. Engineers and emergency crews worked tirelessly to reinforce barriers and divert flows, preventing catastrophic damage to the facility and potential oil spills into nearby ecosystems. The Drift River evacuation and safeguarding efforts became a symbol of the complex interplay between human activity and natural disasters in Alaska's rugged environment. The surrounding communities faced ongoing hardships as the eruptions dragged on. Ashfall remained a persistent problem, blanketing towns and causing widespread damage to machinery, vehicles, and buildings. The abrasive ash clogged air filters, corroded surfaces, and created long-term maintenance challenges for equipment critical to daily life in Alaska's remote regions. Residents had to wear masks and goggles to protect themselves from the health risks posed by the fine particles, which could irritate the lungs and eyes. Roads became treacherous as the ash mixed with snow and ice, creating slippery and unpredictable surfaces. In addition to the physical dangers, the eruptions brought significant psychological and economic stress. Families were displaced from their homes for extended periods, businesses suffered losses, and the cost of disaster response and recovery mounted. For many, the constant uncertainty of when the eruptions might cease added to the emotional toll. Local officials worked alongside federal agencies to coordinate relief efforts, ensuring that food, water, and medical supplies reached those most in need. Community resilience was put to the test as people banded together to support one another through the crisis. Meanwhile, scientists continued their meticulous monitoring of Mount Redoubt's activity. Advances in technology allowed volcanologists to gather data in ways that had never been possible during previous eruptions. Instruments measured everything from seismic activity and gas emissions to the rate at which glaciers were melting. The findings not only helped to inform immediate response strategies, but also contributed to the broader understanding of how stratovolcanoes like Mount Redoubt behave. This eruption became a landmark case study in volcanology, with lessons that would inform future monitoring and preparedness efforts around the world. As Mount Redoubt continued to erupt well into the spring of 1990, it became increasingly clear that this event was reshaping both the physical landscape and the lives of those who called the region home. The combination of natural destruction and human determination would leave a lasting legacy in Alaska's history. As the eruptions of Mount Redoubt gradually waned in the summer of 1990, the immediate crisis transitioned into a period of recovery and reflection. The region, once blanketed in layers of ash and scarred by the powerful lahars, began the slow process of healing. For the people who lived through this event, the eruption left not just physical marks on the landscape, but also lasting impacts on their communities, industries, and scientific understanding of volcanoes. In the aftermath, cleanup efforts became a monumental task. Entire towns had to deal with the thick layers of ash that coated homes, streets, and public spaces. Removing the ash required careful coordination as it posed significant risks to both machinery and human health. Crews used heavy equipment to scrape it away while individuals worked tirelessly to restore their properties. Water systems clogged with ash needed extensive repairs, and local governments faced the challenge of funding these efforts while ensuring the safety and well-being of their residents. The long-term environmental effects of the eruption were equally profound. The ash deposits enriched the soil in some areas, boosting plant growth in the years that followed, but they also caused significant disruption to local ecosystems. Rivers and streams choked with volcanic material, altered their courses, and disrupted fish habitats, impacting the vital salmon populations that so many Alaskans relied on for food and income. Wildlife, too, was forced to adapt to the dramatically changed landscape, and some species faced increased challenges in the immediate years after the eruption. Economically, the eruption's consequences were wide-reaching. The aviation and oil industries, both crucial to Alaska's economy, bore the brunt of the disaster. The grounding of flights during the peak of the eruptions caused financial losses for airlines and disrupted travel for thousands of passengers. The Drift River oil terminal, though saved from catastrophic destruction, required extensive repairs and operational adjustments. For many businesses in affected areas, the cost of recovery proved a significant burden. Despite the challenges, the eruption also brought important advancements in volcanic science and disaster preparedness. The data collected during Mount Redoubt's eruption became a cornerstone for understanding how volcanoes interact with glaciers, how ash plumes affect aviation, and how lahars behave in rugged terrains. This information informed future disaster response strategies, not just in Alaska but globally, as scientists and emergency planners applied these lessons to other volcanic regions. The eruption of Mount Redoubt also highlighted the resilience of Alaskan communities. Faced with one of the most significant volcanic events of the 20th century, people came together to rebuild and support one another. From Anchorage to the small towns near the volcano's base, stories of neighborly assistance and determination emerge as reminders of the human spirit's ability to endure even the most daunting challenges. By the end of 1990, Mount Redoubt had largely quieted, leaving behind a transformed landscape and a wealth of scientific knowledge. While the volcano remains active and continues to be monitored to this day, the events of 1989 and 1990 stand as a testament to the incredible power of nature and the resilience of those who face its wrath. The legacy of Mount Redoubt's eruption lives on, not just in the memories of those who experienced it, but in the advancements it spurred in science, safety, and preparedness. It remains a potent reminder of the unpredictable and awe-inspiring forces that shape our planet, challenging us to learn, adapt, and respect the natural world. The Bhola Cyclone of 1970 is remembered as one of the deadliest natural disasters in human history. This catastrophic storm struck the low-lying coastal areas of what was then East Pakistan, now Bangladesh, with devastating consequences. In the weeks leading up to the cyclone, no one could have predicted the scale of destruction that was about to unfold. This storm would forever change the way the region and the world viewed the threat of cyclones in this vulnerable part of the globe. The story of the Bhola Cyclone begins with the unique geography of Bangladesh. The country is crisscrossed by rivers and bordered by the Bay of Bengal, making it one of the most fertile yet disaster-prone regions in the world. Its flat and low-lying terrain, combined with a population heavily concentrated near the coast, makes it a target for devastating cyclones. During the late 1960s and early 1970s, infrastructure in the region was extremely underdeveloped. Early warning systems were almost non-existent, and the vast majority of the population lived in poorly built homes that offered little to no protection from extreme weather. The vulnerability of the population to cyclones was exacerbated by a lack of awareness and preparedness. Most people in the region relied on traditional knowledge or informal community warnings to determine whether a storm was coming. Unfortunately, in 1970, even these informal networks failed to provide the necessary warnings. Many communities remained unaware of the growing danger until it was far too late to evacuate to safer areas. Adding to the vulnerability was the political context of the time. East Pakistan was struggling under neglectful governance by the central authorities in West Pakistan, leading to significant disparities in resource allocation and disaster management infrastructure. This lack of investment in coastal defenses, emergency shelters, and public awareness campaigns created the perfect conditions for a large-scale human tragedy. By the time the storm began forming over the Bay of Bengal on November 8, 1970, the elements were already stacked against the people of coastal Bangladesh. The warm waters of the bay provided the energy needed to fuel the storm, while the atmospheric conditions allowed it to intensify quickly. As the cyclone grew in strength, it set its sights on one of the most densely populated and vulnerable regions in the world. As the Bhola Cyclone gained strength in the Bay of Bengal during early November of 1970, meteorologists observed the storm with increasing concern. The cyclone's formation was fueled by a dangerous combination of natural factors: warm ocean waters, low atmospheric pressure, and high levels of humidity in the air. These conditions created the perfect environment for the cyclone to rapidly intensify, transforming it into a deadly force. By November 11th, the storm had developed into a Category 3 cyclone, with wind speeds reaching up to 120 kilometers per hour. Despite the growing severity of the storm, communication systems at the time were woefully inadequate. The meteorological agencies monitoring the cyclone faced significant challenges in issuing timely warnings. Advanced tracking technology like satellites was still in its infancy, and many remote areas had no access to radio or other forms of communication. This lack of reliable information made it nearly impossible for officials to warn the population effectively. As the storm approached the coastline, most residents remained unaware of the scale of the danger. The geography of the Bay of Bengal played a critical role in amplifying the storm's impact. The bay's funnel shape naturally directs storm surges toward the coastline, intensifying the force of the water as it nears land. When the Bhola cyclone approached landfall, it pushed an enormous wall of water ahead of it. This storm surge, estimated to be as high as 10 meters, struck the coastal areas of East Pakistan with overwhelming power, inundating entire villages and leaving little chance for survival. On November 12, 1970, the cyclone made landfall near the Meghna River Delta, unleashing its full fury on the densely populated coastline. The storm surge swept through the low-lying islands and coastal plains, submerging vast areas underwater. The combination of powerful winds, relentless rain, and the massive surge created conditions that were impossible to escape. Families in the path of the storm sought refuge wherever they could, on rooftops, in trees, or clinging to debris, but many were overcome by the rising waters. In the immediate aftermath of the cyclone's landfall, the extent of the devastation was difficult to grasp. Entire communities were wiped off the map, and the few survivors who emerged described scenes of utter chaos and destruction. The storm had struck at night, further complicating rescue efforts, and leaving survivors disoriented and terrified as they tried to comprehend the scale of the disaster. In the days following the Bhola cyclone's landfall on November 12, 1970, the scale of the disaster began to emerge, revealing the immense toll it had taken on human life and the region's infrastructure. Reports trickled in from isolated areas, painting a grim picture of destruction and despair. Entire villages were submerged, and survivors were left clinging to life in an unrecognizable landscape. The storm's aftermath exposed not only the physical devastation, but also the harrowing challenges faced by the government and international aid organizations attempting to respond. The cyclone's impact was most severe in the coastal islands and the low-lying delta regions. These areas, densely populated and with little elevation to provide protection, bore the brunt of the storm. An estimated 400,000 people lost their lives, and millions more were left homeless. The sheer scale of the disaster made it one of the deadliest cyclones in recorded history. Survivors described scenes of unimaginable loss, family members swept away by the surge, entire villages flattened by the wind, and bodies strewn across the flooded landscape. One of the most devastating aspects of the cyclone was the breakdown of essential services in its wake. Clean drinking water became nearly impossible to find, as saltwater contamination had infiltrated wells and other freshwater sources. Food supplies were similarly destroyed, with crops submerged under floodwaters and livestock swept away. This created an immediate humanitarian crisis, as survivors faced starvation and disease in the days following the storm. Efforts to bring relief to the affected areas were hampered by the lack of infrastructure and the chaotic conditions. Roads and bridges were destroyed, making it nearly impossible for aid to reach those in need. The few boats available were often insufficient for the task of navigating the flooded areas, and air transport was limited. Relief workers faced monumental challenges as they attempted to deliver food, water, and medical supplies to the survivors scattered across the devastated region. Compounding the crisis was the slow response from the government. At the time, East Pakistan, now Bangladesh, was part of a politically unstable country with a central government based in West Pakistan, more than 1,000 miles away. The geographical distance, combined with political tensions between the two regions, delayed relief efforts and left many survivors feeling abandoned. The lack of immediate action fueled resentment among the affected population and would later play a significant role in the political movements that led to Bangladesh's independence. The environmental toll of the cyclone was equally staggering. Fertile farmland, the lifeblood of many coastal communities, was rendered useless by saltwater intrusion. The flooding disrupted ecosystems, and it would take years for the land to recover fully. The economic devastation was profound, as thousands of families who depended on fishing, farming, and small-scale trade lost their livelihoods overnight. While the world eventually came to learn of the tragedy, the initial international response was slow. News of the cyclone spread gradually, as communication lines were down, and reports took days to reach the global community. When aid finally began to arrive, it was clear that the needs far outweighed the resources available. The devastation caused by the Bhola Cyclone became a haunting reminder of the vulnerability of coastal communities and the urgent need for better disaster preparedness. In the years following the catastrophic Bhola Cyclone of November 1970, the event became a turning point for both Bangladesh and the global approach to disaster management. The cyclone's unprecedented scale of destruction and loss of life prompted critical changes in how governments, organizations, and individuals prepare for and respond to natural disasters. Its legacy continues to shape policies and awareness to this day. One of the most significant outcomes of the Bhola cyclone was the heightened global focus on the importance of disaster preparedness. The tragedy highlighted glaring deficiencies in early warning systems and infrastructure. At the time, warnings for the cyclone were issued, but they failed to reach the vast majority of the population due to inadequate communication networks and the absence of a robust public information system. In response, both local and international entities began investing heavily in more effective early warning technologies, aiming to ensure that such a communication failure would not be repeated. For Bangladesh, which gained independence shortly after in 1971, the lessons of the cyclone were deeply embedded in the nation's development priorities. The newly formed government initiated efforts to build cyclone shelters, elevate infrastructure, and establish community-based warning systems. Over the following decades, thousands of multi-purpose cyclone shelters were constructed across the coastal regions, designed to provide refuge for large populations during future storms. Roads and embankments were also improved to offer better access and resilience against flooding. The Bhola cyclone also played a crucial role in bringing international attention to the vulnerability of low-lying coastal regions. Scientists and policymakers began emphasizing the relationship between climate change and the increasing frequency and intensity of tropical cyclones. While the connection between human activity and global warming was not yet fully understood, in the 1970s, the Bhola disaster was an early indicator of the need to address environmental factors in disaster planning. On the human front, the cyclone sparked waves of political and social change within the region. The failure of the central government in West Pakistan to adequately respond to the needs of the affected areas in East Pakistan led to widespread outrage. This perceived neglect fueled the already growing demand for autonomy, culminating in the Bangladesh Liberation War and the country's eventual independence in 1971. The cyclone therefore not only left an indelible mark on the physical landscape, but also served as a catalyst for a monumental shift in the region's political history. Despite these advancements, the memory of the Bhola Cyclone remains a stark reminder of the immense power of nature and the challenges of safeguarding human life in vulnerable regions. Each anniversary of the disaster serves as an opportunity to reflect on the strides made in disaster management and to acknowledge the ongoing risks faced by coastal communities around the world. Bangladesh itself, while vastly more prepared today, continues to confront new cyclones and rising sea levels, demonstrating the persistent need for vigilance and innovation. The Bhola Cyclone's story is one of immense tragedy, but also of resilience and transformation. The lives lost in November 1970 have left a legacy that has saved countless others by spurring improvements in disaster response and preparedness. This devastating event remains a powerful reminder of the fragility of human life in the face of nature's fury, and the enduring importance of learning from the past to build a safer future. In the autumn of 1979, meteorologists monitoring the Pacific Ocean began to notice the early signs of what would become one of the most powerful tropical cyclones in recorded history. It all started with a tropical disturbance near the Marshall Islands. At first, it seemed unremarkable, a cluster of thunderstorms brewing in warm ocean waters. But as the system began to organize, meteorologists could see it was no ordinary storm. The warm waters of the Pacific Ocean, combined with favorable atmospheric conditions, provided the perfect environment for the disturbance to develop. Sea surface temperatures in the region were unusually high, exceeding 80 degrees Fahrenheit, creating a vast reservoir of energy. At the same time, low wind shear, a condition where winds at different altitudes are not drastically different in speed or direction, allowed the storm to maintain its structure and grow rapidly. As the storm gathered strength, the Japan Meteorological Agency officially classified it as a tropical depression on October 8, 1979. By October 9th, it had intensified into a tropical storm, earning the name Tip. Over the next few days, Tip's growth was extraordinary. It transformed from a modest tropical storm into a full-fledged typhoon, its spiraling bands of clouds stretching farther and farther across the ocean. By October 11th, Tip reached the status of a super typhoon. At its peak, the storm boasted winds of over 190 miles per hour and a minimum central pressure of 870 millibars, the lowest ever recorded for a tropical cyclone. These figures alone make Typhoon Tip a meteorological marvel, but the storm's size was equally astonishing. At its largest, Tip's circulation spanned over 1,380 miles in diameter, making it the widest tropical cyclone ever documented. The immense size and power of Tip were not just theoretical measurements, they represented a serious threat to anyone in its path. Meteorologists faced the daunting challenge of predicting where the storm would go and how intense it would become. In an era without modern satellite imagery or advanced computer modeling, this task was as much an art as it was a science. Using weather balloons, aircraft reconnaissance, and early satellite data, they worked tirelessly to track Tip's progress. By mid-October, Tip had become a storm that defied imagination. Its enormous eye, a calm, eerily clear area at the center of the storm, measured over 20 miles across, surrounded by towering walls of clouds where the most violent winds and heaviest rains churned. This was the calm before the chaos, as the typhoon approached areas where its impact would be felt most acutely. Communities across the Western Pacific scrambled to prepare. In Japan and nearby islands like Guam, authorities issued evacuation orders, closed schools and businesses, and braced for the storm's arrival. People boarded up windows, secured their belongings, and sought refuge in designated shelters. Despite the best efforts of forecasters and officials, the sheer scale of Tip's power made it impossible to predict the exact extent of the destruction that lay ahead. Part 1 of this journey into Typhoon Tip's history ends here, with the storm at its peak intensity and a sense of unease hanging heavy over the Pacific. The next part will delve deeper into Tip's path and the impact of this colossal storm on the people and places in its way. As Typhoon Tip reached its peak intensity in mid-October of 1979, its immense size and power set it apart from any storm in recorded history. With its towering clouds, vast wind field, and record-breaking low pressure, Tip became a force of nature that demanded respect and fear. The storm's trajectory was closely monitored as forecasters worked tirelessly to predict its path and issue timely warnings to the regions at risk. Tip began its journey westward across the Pacific, its spiraling arms stretching out over 1,380 miles. The storm churned through open waters, gathering moisture and energy from the warm ocean surface. While the storm's eye remained a quiet center of calm, the surrounding eye wall was a region of unrelenting chaos. Wind speeds soared to over 190 miles per hour, accompanied by torrential rains that poured down in sheets, obscuring visibility and creating treacherous conditions for ships at sea. As the storm moved closer to land, the Japanese island of Guam found itself in Tip's vast outer reach. Although the island was spared a direct hit, it still faced strong winds, heavy rains, and rising seas. Coastal areas were inundated by storm surges, forcing evacuations and leaving residents grappling with power outages and flooded homes. Fishermen scrambled to secure their boats, and emergency responders worked around the clock to protect lives and property. While Guam experienced only a glancing blow, Japan's southern islands braced for the storm's full impact. Typhoon Tip shifted slightly northeast, sparing the most populated regions a direct hit, but still unleashing its fury on the Ryukyu Islands. Strong winds tore through towns, toppling trees and power lines, while torrential rains caused landslides that buried roads and threatened entire villages. At the same time, the storm's massive circulation caused ripple effects far beyond its immediate path. In the Philippines, hundreds of miles away, heavy rains brought by Tip's outer bands triggered flash floods and displaced thousands of families. The storm's sheer size meant that even areas not directly in its path felt its influence, underscoring the far-reaching impact of such a powerful system. Tip's eventual landfall came on October 19, 1979, in Japan's Shikoku region. By this point, the storm had weakened slightly from its record-setting peak, but it remained a formidable typhoon, with winds exceeding 120 miles per hour. Coastal towns bore the brunt of the storm surge, which swallowed entire stretches of shoreline, destroying homes and businesses in its wake. Farther inland, rivers swelled beyond their banks, inundating fields and towns and forcing thousands of residents to flee to higher ground. Throughout the chaos, stories of survival and resilience emerged. Families huddled together in shelters, clinging to hope as the storm raged outside. Emergency services worked tirelessly to rescue stranded residents, wading through floodwaters and navigating debris-strewn streets. The storm's impact on infrastructure was severe, with countless buildings reduced to rubble, roads rendered impassable, and communication networks disrupted. As Tip moved inland and began to lose strength, it left behind a trail of destruction that stretched for hundreds of miles. In the storm's wake, survivors emerged to assess the damage and begin the long process of recovery. Yet even as the winds died down and the rain subsided, the true scale of the disaster was only beginning to become clear. Next, we will explore the aftermath of Typhoon Tip, delving into the human toll, the challenges faced by those left in its path, and the lessons learned from this unprecedented storm. When Typhoon Tip finally dissipated in late October of 1979, the devastation left behind was staggering. Entire communities were unrecognizable, transformed by the relentless winds, rain, and storm surges that had accompanied the storm's passage. For the people who had endured its wrath, the aftermath was a time of reckoning, survival, and rebuilding. In Japan, the storm's impacts were most severe in the Shikoku and Honshu regions. Entire neighborhoods had been submerged by flooding, with homes and businesses reduced to soggy ruins. Farmlands, which were the lifeblood for many communities, were devastated as rivers overflowed, carrying away crops and livestock. Coastal towns suffered extensive damage, with fishing fleets destroyed and ports rendered unusable. One of the most immediate concerns was the displacement of thousands of residents. Shelters quickly filled with families seeking refuge, many of whom had lost everything. In the days following the storm, emergency response teams worked tirelessly to deliver food, clean water, and medical aid to the affected areas. However, the sheer scale of the disaster made it a daunting task. Roads were blocked by landslides and debris, making it difficult for supplies to reach remote locations. The human toll of the storm was deeply felt. Dozens of lives were lost, and many more were injured. Hospitals were overwhelmed with patients suffering from storm-related injuries, and there was a growing concern about the spread of waterborne diseases due to the contaminated floodwaters. Volunteers and aid organizations rallied to support those in need, but the emotional scars of the disaster were evident in every survivor's story. Beyond the immediate challenges, the long-term effects of Tip were profound. Infrastructure across the region was severely damaged, with roads, bridges, and power lines needing extensive repairs. In some areas, it took weeks or even months to restore electricity and clean water. Schools and public buildings that had been used as evacuation centers required significant renovations before they could reopen. Environmental damage was another pressing issue. Forests along the typhoon's path were left in shambles, with uprooted trees scattered like matchsticks. Coastal erosion altered the landscape, and the storm's intense rainfall led to soil destabilization, increasing the risk of future landslides. Efforts to clean up and repair the damage required coordination between local governments, national agencies, and international aid organizations. As the recovery unfolded, stories of resilience and solidarity emerged. Communities banded together to clear debris, rebuild homes, and support one another through the hardships. Local leaders organized fundraisers and donation drives, while neighboring regions sent resources and manpower to assist in the recovery efforts. Despite the immense challenges, there was a collective determination to overcome the disaster and restore a sense of normalcy. In the months that followed, meteorologists and scientists analyzed Typhoon Tip's unprecedented strength and impact. Its record-breaking size and intensity highlighted the need for improved forecasting technology and disaster preparedness. Governments across the Pacific region began reassessing their emergency response strategies, seeking to learn from Tip's devastating lessons to better protect their citizens in the future. As we wrap up, we will reflect on the legacy of Typhoon Tip, examining how it changed our understanding of tropical cyclones and the ongoing quest to predict and mitigate such powerful forces of nature. Typhoon. Tip's story did not end when its winds subsided or the floodwaters receded. Instead, the storm left an enduring legacy, one that reshaped our understanding of tropical cyclones and the ways we prepare for natural disasters. In the decades since Tip's unprecedented arrival in 1979, its lessons have influenced meteorology, disaster management, and public awareness in profound ways. One of the most significant impacts of Typhoon Tip was its contribution to meteorological science. At the time, the storm's size and intensity were unparalleled, pushing scientists to study its unique characteristics. Researchers examined how Tip's interaction with warm ocean waters and atmospheric conditions created the perfect environment for such a colossal storm to form. This research not only deepened our understanding of typhoon dynamics, but also helped improve predictive models, enabling forecasters to anticipate storm behavior with greater accuracy. Tip also highlighted the importance of advancements in storm monitoring technology. In the late 1970s, satellite imagery was still in its early stages, and weather data collection relied heavily on reconnaissance aircraft and surface observations. The challenges of tracking Tip underscored the need for more robust satellite systems, which have since become essential tools in monitoring tropical cyclones worldwide. Today, meteorologists can track storms in real time, providing earlier warnings and saving countless lives. On a societal level, Tip served as a wake-up call for disaster preparedness. Communities and governments across the Pacific Basin recognize the critical importance of early warning systems, evacuation protocols, and infrastructure resilience. In Japan, where the storm's impact was most severe, efforts were made to strengthen coastal defenses, improve flood management systems, and educate the public on how to respond to typhoons. These measures have undoubtedly reduced the toll of subsequent storms in the region. The human stories of Typhoon Tip, of loss, resilience, and recovery, also played a pivotal role in fostering a deeper appreciation for the power of nature. Survivors' accounts of the storm's fury and its aftermath served as a stark reminder of the vulnerability of coastal communities. These narratives helped galvanize support for stronger disaster response programs and greater investment in community preparedness. Globally, Tip's record-breaking intensity became a benchmark in the study of tropical cyclones. The storm's name remains synonymous with extreme weather, and its place in history has influenced how we perceive and respond to similar events. It also spurred international collaboration among scientists, governments, and organizations working together to mitigate the impacts of future storms. While Typhoon Tip was a natural disaster of immense destruction, its legacy is also one of progress and resilience. The storm's unprecedented power challenged humanity to rise to the occasion, to learn from the devastation, and to build a future where we are better equipped to face the forces of nature. The advancements in meteorology, disaster management, and community preparedness that followed in Tip's wake stand as a testament to our ability to adapt and endure. As we reflect on the history of Typhoon Tip, we are reminded of the duality of nature's beauty and its potential for destruction. It is a call to action to respect the environment, prepare for the unpredictable, and remain steadfast in the face of adversity. Typhoon Tip may have been a storm of the past, but its lessons are timeless, serving as a guide for navigating the storms of the future.